All right, let's match each equation with the most suitable graph. Explain your reasoning. Right, so part A, we have f of x is equal to 2x plus 1 squared and x minus 3. Now here we actually, in order to match the sketches, we need to actually look at the order or the multiplicity of each root, right? So if we look at part A, I'm just going to write some of the characteristics down, right? The roots here, you can find the roots by letting f of x equals 0. So if I let f of x equal 0, you get 2 times x plus 1 squared. X minus 3 is equal to 0. And it's just as simple to solve for the roots. It's just as simple as letting each factor equal 0. Like I let x plus 1 equal 0. X is equal to negative 1. So negative 1 and 0 is one of my roots. The other root here is x minus 3 equals 0. X is equal to 3. So 3 and 0 is another one of my roots. Now you can notice here that the degree on your first root, or the order on your root here, right, is negative 1 and 0. The order here is basically 2, right? And because the order is 2, the behavior of this is going to be concave to negative 1 and 0. Okay? And the order at 3 and 0 here should be 1, because you can see a 1 there, right? And that means that it will slice, or it'll pass through. So it'll slice through 3 and 0. Yeah? So something that's concave to negative 1 and 0 and that slices through 3 and 0, the only scenario that would work out would be part C. Okay, so we already looked at part C. All right, let's take a look at part B here. Right, you do the same technique. So the roots here, order, behavior. Okay, so the roots here for part B is negative 1 and 0 as well, and 3 and 0. Negative 1 and 0, we have an order of 2. 3 and 0, we also have an order of 2. And basically, it's concave to these points. So a scenario where it's concave to both points would be part A, right? So A would be the only scenario where that actually works, right? So this is A, right? So we said that this is C, this is A. Let's take a look at part C, right? So I'm just gonna show you, you know what, I could probably fit some space here. If you're looking at part C, right, let's look at roots, order, the behavior. Okay, so in part C, the roots here are negative 1 and 0. Right, and the other root here is 3 and 0, and you can see that the order here for negative 1 and 0, for x plus 1, it's power 1. So it just basically slices through, or passes through. Right, I like using slices through, it's easy to remember. And then 3 and 0 here, the order here is 2, so it basically is concave to this point. So it's concave to 3 and 0, but slices through negative 1 and 0. Well, the only case that actually works out is B, right? So basically this guy, right? And by default, D is going to be basically part D, right? And you can notice that the roots on part D here, right, I'm just going to use a different color, but the roots are, if you let f of x equal 0, you get 0, negative 1, 3, and 5, right? And the order for all of these, order of all factors are 1. So if the order of all factors are 1, it basically slices or passes through each root, right? And the only case where it does that is going to be D. Good? So this is going to be D. So it's going to go C, A, B, D.